Alrighty, let's review a bit before we jump into this lesson. Alright, if I have something that looks like this, 4x parenthesis 3x plus 6. Okay, well, I know that the way I'm going to solve this, I've got a number right here outside the parentheses, and these two are all squished together. That means I know I'm multiplying here. Okay, anytime I have a number right outside the parentheses, I know I'm going to solve this by distributing. Distributing is just multiplying the number on the outside by each of the numbers on the inside of the parentheses. Okay, so let's give this a try. What I've got here, I'm going to end up with 4x times 3x. Okay, so I just followed along with this first line right here, this short line. Okay, and I got 4x times 3x. Now I'm going to go ahead and I'm going to follow along with this red line right here, and that's going to give me, okay, plus 4x times 6. Okay, so at the end of this, I should have, okay, 4 times 3 I know is 12. X times x I know is x squared. Okay, so that takes care of this part. Plus, let's see, 4 times 6, I know that's 24. X times nothing, okay, well, that's just an x. Okay, fantastic. So what I've done here is I started, let me get the laser pointer, here we go. I started with something that looks like this, and I ended with something that looks like this. The lesson for today is doing this exact same thing, but backward. We're going to start with something that looks like this, and we're going to figure out what the greatest common factor is, or in other words, what number can I take out of the equation. Okay, so let's see, here I have the assignment. If I'm looking here at problem number 1, I'm looking for the greatest common factor. Let's break that down. Greatest, well, that's another word for biggest. Common, well, that's another word for same. And factor, those are the numbers that we multiply. So I'm going to put a multiply sign there. Okay, so I'm going to start by listing out the factors of 15. So what are two numbers that can multiply together to get to 15? If this part takes you a minute, that's okay. I just am good at this part because I've practiced my times tables. But if you need to pull out your calculator, spend a little time on this, that is great. So 15, I know 3 and 5 are factors of 15. The other ones I can think of are 15 and 1. And I think that's about it. Okay, and then how many m's do I have? Well, since I have to the third power right there, I know I have 3 m's. So 1, 2, 3. Okay, I'm going to do the same thing. I'm going to factor 10. Okay, things that go into 10, I know 2 times 5, and I know 10 times 1. Those are 10's factors. And how many m's do I have? Just 1. All right, fantastic. So, biggest. Okay, so I'm looking for the biggest number in each of these lists. Common. Okay, so I'm looking for the biggest number that both of these lists have in common, and then factor, well, here are my lists of factors. So I'm looking for the biggest number that these two lists have in common. It looks like both of these lists have a 5, and that's the biggest number they have in common. Some people asked me, well, Miss Gunther, they also both have a 1. You're exactly right. That would be a common factor, but we're not looking for just a common factor. We're looking for the greatest common factor, or the biggest common factor. So I'm going to go with these 5s. And then how many m's do they have in common? Well, it looks like this list over here, the 15m cubed, has at least 1 m, and 10m also has at least 1 m. So what we've done here is we found the greatest common factor. The greatest common factor is the number that we're going to take out. Okay, 5m. I need to see what is going to be left of this equation after I take out 5m. Okay, so what's 15 divided by 5? Well, I know that that's going to be 3. Okay, and if I have if I have 3 m's and I take away 1, how many m's do I have left? I'll have 2 m's, or m squared. Okay, let's do the same thing for this other term. Okay, so what is 10 divided by 5? Well, I know that that equals positive 2. Okay, and if I have 1m and I take away 1m, how many m's am I left with? 0 m's. So I could write this m to the 0th power, or if I wanted to save a step, I could just not write it at all. Okay, so what we've just done is found the greatest common factor for both of these terms, and then we divided this term and this term by the greatest common factor to see what we would have left. Let's try it again. Okay, I'm over here on problem number 2. Once again, I'm going to start by just listing the factors. If you need to take a second, pull out your calculator and try this on your own, fantastic. Go ahead and pause this video. Alrighty, I'm looking for the factors of 32. I know 2 times 16 is factors of 32. I know 8 and 4. I know that we've got 32 and 1. And I think that's about it. All right, and then how many a's do I have? Well, since I've got this a to the 4th, I've got 1, 2, 3, 4 a's. Okay, fantastic. I'm going to go ahead and factor 40. Let's see, for 40, I know I've got 40 and 1. I've got 2 and I've got 20. I've got 10 and 4. And I've got 8 and 5. Okay, fantastic. And then how many a's do I have? Just 1. Okay, since I'm looking for the greatest common factor, I'm looking for the biggest number that these two lists have in common. Spend a second looking at these lists. It looks like the biggest number that's on both of these lists is 8. Okay, and how many a's do they have in common? Well, it looks like this over here, they have at least one a, and we've got at least one a right here. So I know that my greatest common factor is going to be 8a. Okay, fantastic. Now I need to see what's going to be left of each of these terms after I take out 8a. To figure that out, I'm going to divide each of these terms by 8a. So what's left of 32 after I divide it by 8? Pull out your calculator and try this. I know that 32 divided by 8 gives me 4. And what's left of 4a's after I take out 1? Well, what's left is going to be 3a's, so a to the 3rd. Okay, let's look at this one over here. Here I've got 40, a to the 1. Okay, what's left of 40 after I divide it by 8? Pull out your calculator if you need to. I know that this one is going to give me 5. 40 divided by 8 is 5. And then if I have 1a and I take away 1a, how many a's are left? None. So once again, I could write it like this, a to the 0, or I could just not write it. Okay, so once again, what we did was we factored each of these numbers. We found the greatest common factor. We took it out. And then to see what was left, we divided our greatest common factor by our original terms. Let's do one more together. Let's try to bump it up a notch. Oh, how about this one? Okay, fantastic. I'm going to start by factoring these. Okay, the factors of 7 are, okay, let's see, just 7 and 1. I think 7's prime, so just 7 and 1. Okay, and how many x's do I have? Oh, it looks like I've got 7. 1, 2, 3, 4, 5, 6, 7. Okay, and what are the factors of 4? Well, I know 4 and 1, and I know 2, because 2 times 2 is 4. And how many x's do I have? 1, 2, 3, 4, and 5. Okay, fantastic. Let's see, what is the greatest common factor between these two numbers? Oh, this is unusual. It looks like it's 1. Okay, what's the biggest number that these two lists have in common? It looks like 1. Okay, that's fine. So I know I'm going to take out a 1. And then how many x's do they have in common? Well, let's see. It looks like they both have at least 5 x's. Okay, so I know then, let me circle that. They have in common 5 x's, so I'm circling everything that they have in common. So I know that I'll probably take out 5 x's. Now, hopefully some of you have noticed, Miss Gunther, 1 times x to the 5th is the same as just x to the 5th. Anything times 1 is just itself, so that 1 didn't change anything. So if I wanted to simplify this as much as I can, I would write it just x to the 5th, and I wouldn't put the 1 in front. If you do want to leave the 1 in front, that's fine. Alrighty, let's see what's going to be left of this expression after I take out x to the 5th. Well, let's see, what's 1 divided by 7? Oh, it's still 7. Alright, and if I have 7 x's and I take away 5, how many x's do I have left? Just 2. Alrighty, let's try this other one. If I have what's what's negative 4 divided by 1, well, I know that's just going to be negative 4. And then how many x's do I have left if I start with 5 and I take away 5? Yeah, I'll have 0 left. So I could write it like this, or I could just choose not to write it. Oop, everything jumped around. Where did I go? Whew, we're back. All right. Okay, give the rest of these problems a try. If you have any trouble, please send me an email or just come up and ask me, and we'll get you the help you need. Good luck. You guys got this.